Hello, everyone. Good morning. Bom dia. Thank you so much for attending that event. Thank you for being today to attend the SAE Smart Track US UK Network. My name is Leandro Garbin, and today I will be the mediator of this event. I work for Siemens over here in Brazil at the Digital Industry Software, and I am the portfolio executive. First of all, thank you so much, Mr. Marco Colosio and Erwin Franiek, to trust on my job. And first of all, even I really would like to thank this event, exclusively the sponsor, British government in Brazil and UK Department of International Trade, DIT. So before we start, we have some information, some important information over here for you. We kindly ask you to the all attendants to keep this camera and audio off during the entire event, please. The all questions should be written by chat. Please note that this event is being recorded, okay? And will be available on SAE Brazil YouTube channel next week. So, okay, on next week will be available this recording. If you have some question, as I told you, you can chat, you can write over here by chat. And this event, the governments of Brazil and UK are together on this event, working on this project to expand the all knowledge about aluminum, plastic material, and steel with the major market players in both countries. So the panels which will be happen today, it's really an excellent opportunity for network and of course to learn about some possible applications. I really would like to invite Mr. Douglas Barnes. He is the head of DIT of Advanced Engineering. Mr. Douglas, he spent more than 30 years working on the international trade promotion on business support experience working in UK companies. He spent more than 11 years working on trade promotion in China, Vietnam, and Myanmar, and his main objective
I hope everyone can hear me because I lost the sound, Leandro. So I'm not sure if everyone can hear me. Could you give me an indication that I am being heard?
I can hear you.
Okay,
I
great.
can hear you.
Good morning and good afternoon to everyone, depending on where you are. First of all, thank you very much for this opportunity to speak today at this event. I just want to give you a little bit of background about the Department for International Trade, and then I'll talk really about our objectives for this event and why we have joined with SAE to put the event on. So we are a ministry within the UK government, and our remit is to promote trade, to encourage and support UK companies who are exporters to countries throughout the world. We're also tasked with identifying and supporting foreign direct investment into our economy. And in my team's case, we focus primarily on the advanced engineering and advanced manufacturing sectors. We provide this support to UK companies by this kind of event that we have on today, but also we have over 100 British missions throughout the world, similar to the one that's in Sao Paulo and in other parts of Brazil, where we then work through our headquarters here in London and with our colleagues in those countries to support bilateral relationships. I would like to thank SAE Brazil for partnering and hosting this event. It's very much appreciated. And I would also like to thank in advance the speakers and presenters from both UK and Brazil. So I mentioned that there are sort of key objectives. So there are 4 objectives from our perspective that we would like to get out of today's event. Firstly, we aim to provide a better understanding of UK capabilities within the 3 sectors, i.e. Steel, aluminium, materials, and plastics. Secondly, we want to understand a little more about the dynamics of the sectors in Brazil. And hopefully from this event, we'll identify some opportunities for bilateral business relationship. So business opportunities on both sides. And the third objective is to identify and discuss areas of concerns such as tariffs and market access barriers. Those are key issues that British exporters, not just in these sectors that we're focusing on, but in general, are always concerned about. So during the course of the event and also at the end, I hope we'll be able to address some of these issues. And the fourth and final objective, I hope this will be a catalyst to start a dialogue and a connection for a bilateral relationship between our 2 countries, particularly those participating and listening in both countries. So we will continue after this event to work with colleagues to see if we can enhance the already vibrant export opportunities that we have supported many UK companies to do business in Brazil. So in closing, I'd just like to say, I look forward to what I am sure will be a fruitful discussion during this event and to working with all or most of you post this event. Thank you very much, Leandro.
Great. We really appreciate Mr. Barnes. Thank you so much. Right now, as I told you in the beginning, we just share this event in 3 panels. So the steel, aluminum, and plastics. For the first presentation, I really would like to invite Mr. Bashan Berkot. He will talk about electrification. He is the electrification transition manager at Tata Steel. Mr. Berkot is located in Netherlands, and he works for Tata since 2003 with various roles in the research and development organization, and since 2011 in the Automotive Market department. His current role is the electrification transition manager. In this role, he is responsible for the electrification strategy and operational market mix for this dynamic and fast developing market. So, Mr. Bashan, could you please start your presentation? How are you today?
Yeah, very good. Thank you, Leandro, and thank you for inviting me for this event today.
Great, we really appreciate.
Yeah, no, you're welcome. And I hope you can all hear me indeed. Today I would like to present to you about Tata Steel and Tata Steel's view on electrification. So that is the topic for today, but basically before I start, I would like to first show a bit what Tata Group is and also what Tata Steel is all about. Because maybe not all of you know the company. Basically, if you look at the slide here, then of course Tata Group is maybe known to you. It's a very big Indian company, present in about 100 countries with 750,000 employees worldwide, with a revenue over 100 billion in the past year. And if you look at that conglomerate as it is, of course we are active in very different industries. Here you see a few of the examples where, for example, we have Tata Motors, who's making trucks, but also passenger cars. So, for example, Jaguar Land Rover is part of the Tata Motors group. We have power, we have chemicals, we have hotels. So there's really a lot of businesses underneath the Tata flag. And one of the larger companies under the Tata flag is also Tata Steel, who is a company that is actually present also across the globe. has about 10% of the amount of employees of the Tata Group, and is a Fortune 500 company, and is located in Europe, so that is the Netherlands and the UK, but also, of course, in Asia, in India, in Thailand, Singapore, and so on. So really with a global presence. And I am myself representing the European part of this business with a global responsibility for electrification. And the European industry is basically situated in the Netherlands as well as the UK, with core steel production and downstream processes for a number of different sectors, which we provide our customers with across the globe. And yeah, we have the products and the related services to also support our customers in the journey towards more and better optimized products. And if you look at the share of the automotive sector within that total portfolio, it is about 30%. So I think that is good to understand when we go into the further presentation about electrification, that Tata Steel is part of the Tata Group and is indeed a big company that is supplying customers across the globe with valuable products. Today, I would like to address a part of this overall company, which is in this case particularly about electrification. So the Eevee offering that we are working on as Tata Steel. And this is, of course, all recognized as being a mega trend in the market, electrification, but also, of course, autonomous driving and shared use. Those are all trends that will be influencing the way forward for automotive. And well, we basically see them, and I think this is a common understanding that, of course, electrification especially is just not a single independent thing. It's part of something bigger, which is the target of all the companies worldwide and of society to be a more sustainable business, a more sustainable society for the future generations. I think the pressure or the speed of transition that you now see in the automotive industry towards electrification is, of course, it can be related to the sustainability and corporate social responsibility trend. And then if you look at digitalization, which is, of course, maybe the third mega trend that you can observe, of course, this is a way to actually facilitate all these new areas and new possibilities by advanced digital technology. And I think today we are witness of this with an event like this with quite a number of people attending, which in a very difficult situation for the world with the coronavirus, allowing us still to have very good meetings, very good events. So I think this is just an example of how that also will become true for other areas. If we look at what Tata Steel is doing, especially in these areas, then we are working on roadmaps for more sustainable steel production. Going forward, we have a target to reduce our CO2 emissions in 2030 by 30 to 40%. We also strive to actually have a carbon neutral production latest by 2050. So this is a very big activity that we're working on. We are working on digital strategies as well, but those topics I will not address today. Today is about electrification, which is also a very good opportunity. It's an opportunity for society to become greener. It's an opportunity for businesses to generate new value, new opportunities. And this is exactly what Tata Steel is working on at the moment, already for a few years. And I think now the first signs of real good progress and alignment are there. So our mission is really to support our customers in the creation of more sustainable electric vehicles. And we do this by helping our customers with more efficient, affordable, and also environmentally friendly products in a unique range that I will show today. But of course, also the knowledge and understanding behind that in order to be able to use those products in the best way possible. If we look at that complete offering on the highest level, you could say that if you distinguish three important areas of an electric vehicle, that is, of course, the motor itself that is generating the power to be able to move that vehicle forward. The energy storage solutions, the battery that makes sure that the ranges there's a proper range. That also, if you go to a charging station, this can be done in a fast way. And in the end, of course, if you are a user of a vehicle, you would like to be safe in that vehicle. And as always, the crash management is really important. And we could say that for an EV, because of the different way it is designed, because of the different components, they all relate to each other. All these aspects are influencing each other in certain ways. And as Tata Steel, we try to take a holistic approach towards an EV design and production by offering a number of products, which I will explain a bit further. Those are products in the area of motors with highlight, a non-grain-oriented steel for electric motors. We have ultra-clean steels for battery solutions, for the cans of those. And we have, of course, solutions for the EV crash management with XPF and Hyperform, which I will explain. I'll just quickly touch upon these products because we don't have endless time today. First of all, highlight. Well, as I mentioned, this is a non-grain-oriented electrical steel range, going from a 30 NO30, which is 0.3 millimeter, down to 0.1, allowing you, a car designer and an e-motor manufacturer, to reduce the inefficiencies in the motor. And this is by offering steels with a low magnetic loss and high strength that allow the designer to actually make the motor in a way that is cost effective, that is basically lightweight. You see here that the example is even talking about a size reduction of 30% and a weight reduction of 60%. And that is really there because the weight is continuing to be important for even an EV. And also the size is because of the passenger compartment in the vehicle being as large as possible. So these advanced steels are being produced in our daughter company Surahammar in Sweden. And this is something that we are actively working on in terms of also developing new products. If we look at a different area, the battery, which is of course very closely related and also a very important element in the e-drive powertrain, then we talk about, of course, the cell itself. It should be very clear that if you make a battery, the cell is really important. The energy density in the cell is of huge importance, and if you move from the cell to the module to the pack level, of course, you need to make sure that inherent energy density that you have in the cell is maintained in the best way possible. With Hillamine, this is something we strive for. So the product is a very clean, drawable steel that is being used in cylindrical cell batteries. And a number of you might know, some of the companies that are using these solutions, which have vehicles with very good ranges and very good performance. At the moment, it is a steel that also makes a difference there, because it allows the vehicle to be produced in a very cost-effective way, very reliably, and with very high performance. And as a steel supplier in this area, we support our customers in that. The companies that are involved in this are based in US with Thomas Steel and in Europe with Hiller-Müller in Germany. And from that basis, we supply our customer with this product. This is something that, of course, we will continue to do and continue to develop as well, going towards the future. Then maybe last or third topic of today, which is the EV crash management area. There we also have an offering, which is of course an extension of the traditional offering for body in white and chassis applications, but now with a specific focus on the electric vehicles, because we recognize that an electric vehicle is something different, is designed in a different way, and hence the material requirements will be different than for a ICE powered vehicle. If you look at the grades that we currently have in our portfolio, if you just look at hot rolled and cold rolled advanced high-strength steels, you see that we have a range of products there with strengths going from 600 to 1,000 megapascal and even above, with the combination of high strength and very good ductility. And you basically see a number of these grades which we regard to be especially suitable for EV applications. And those are now highlighted. And the special thing about these products is that they combine a high formability with a very, very high strength, which is actually required in an EV because it allows a designer to have more design flexibility. The EV crash management is more complicated because you need to make sure that you are basically managing a more complex crash management situation in an effective way. And in order to have the freedom to design that into a body in white effectively, you should make sure that you have the materials with the right properties, and that is mostly having the ability to have high formability and high strength in one product. And that's exactly what these products offer to the market, to the customers. Just taking two examples of that with some concrete case studies behind it. If I just play this movie here, you see a front crash module of a ICE on the left-hand side compared to a electric vehicle on the right-hand side. And you basically see on the top level how the front module is being changed if you move from an ICE to an EV. It's a different type of crash. It is something that needs to be changed in order to get the right crash performance in a crash test. And this product range, the XPF and Hyperform, allows you to combine hot rolled and cold rolled steel grades in this area in order to achieve a lightweight design of the front module with the best crash performance possible. If you look at this, the side impact, this is even maybe more difficult than it is for an ICE, because now you have this battery in the floor of the vehicle mostly, and you need to make sure that in a very short distance you absorb the energy and you keep the passenger safe. So you really need to find the balance between the peak force and the deceleration of the passenger and absorbing the energy in a safe way possible without penetrating the battery. And for this, we have a number of grades in development in the hot forming portfolio, which at the moment range between 1000 and 1900 megapascal, where, of course, for the specific application, you choose the right product. And we have, of course, the ideas around that, and we have the developments ongoing to have these products available for the market. Yeah, so that was, in short, in a nutshell, basically the things that Tata Steel in Europe is working on. As indicated, we are a European company. We are basically located in the UK and the Netherlands. And we are definitely willing and very enthusiastic to support you if you have any queries about these products and offerings. Thank you very much for your attention.
Great, Bashan. We really appreciate. I really like that kind of application, mainly for crash tests. I already have worked on this kind of subject. It's really an amazing. The material behavior, really nice, really nice. We really appreciate. Thank you so much. So, gentlemen, right now I really would like to invite a Brazilian presentation. Right now, I'd like to invite Mr. Alexandre Cortese. He is the automotive project specialist at Arcelormittal, flat carbon in South America. And today he will talk about advanced high-strength steel for the automotive industry. So Alexandre has more than 20 years of experience in the industry, of which one of that 20 years dedicated on the automotive developments. And nowadays he is located in São Paulo, over here in Brazil. Currently, he is working at ArcelorMittal, as I told you, focus on support at the automotive and auto parts industries. Since that the project concept, so nowadays he's working at the auto part industry. Sorry, and since the project concept development, aiming for safety, for reduction CO2 emissions, costs, and for lightweight design, working on advanced high-strength steel, ultra high-strength steel, and PHS. Welcome, Alexandre.
Okay, thank you. Could you hear me?
Yes, I can hear you, and I can see you too.
Okay, thank you. And
Alexandre, just a second, please. Maybe he has some troubles on the signal. No. Thais, can you hear me?
I can hear you, Leandro.
Oh, great. I appreciate it. Maybe Alexandre Cortese has some trouble on his presentation. Let's just wait a few seconds. Yes, great. Thank you. Thank you, Rafaela. Yes, that's the risk, no, Erwin. That is the risk. It's okay. He's coming again.
Hello?
Yes.
Yes?
Super. So I suppose that you click in a wrong button, no?
No, I think that my internet had a problem.
Oh, super. Right now
Yeah.
I can see your presentation and I can hear you very well.
Okay. Garbin, do you think that I can just turn off my camera? I think that
Okay.
because... Okay, sorry.
Okay, go ahead. Go ahead.
Okay. Oh, thank you for introducing me. I am very happy to participate in this event. I would like to thanks for all people involved on this organization. Okay. So today I will bring to you something about advanced high-strength steel for automotive industry that we have done not only in Brazil, but also around the world. Okay. So can you see my screen right now? Yeah.
Yes, it's
Okay.
going well. Go ahead.
First of all, I would like to present about ArcelorMittal. We are the largest and the most global steel and mining company in the world. We have approximately 200,000 employees across 60 countries with 1,400 research. We have industrial presence in 90 countries, spanning 4 continents. And we are leader in all major global steel markets, including automotive, construction, home appliances, and the packaging. We also leading research, development, and technology, as well as sizable captive supplies of raw material and outstanding distribution networks. Okay. So we have research and development spread around the world, and we had the global leader in steel research and development across all key industry sectors, including automotive. We are committed to sustaining leadership position well into the future and ranked amongst the world leaders in steel for research and development, with a significant focus on automotive application. Just to have an idea, more than 8 new products under developing at any one time is possible in our R&D. Most products designed initially for automotive industry and later applied for other markets. Key products and innovations in automotive steel industry in the past 10 years have come from ArcelorMittal R&D teams. Okay. About ArcelorMittal Brazil, we are formed by ArcelorMittal Tubarão, ArcelorMittal Vega for flat products, and for long products we have ArcelorMittal Acindar and ArcelorMittal Sulfluminense. Over 14,000 direct employees, 29 business units in Brazil, Argentina, Venezuela, and Costa Rica. The annual production capacity is around 12.5 million tons per year. We are the largest steel producer in Latin America. In the next slide, I will highlight the flat carbon units. Mainly for flat carbon, ArcelorMittal Tubarão and Vega. Okay. So Tubarão is responsible to produce around 7.5 million tons per year and has 5,500 employees. The main products are semi-finished steel, mainly slabs and the hot rolled coils. And the plant started the operation in 1983. Related to ArcelorMittal Vega is the downstream plant that we have in Brazil. We have the capacity around 1.4 million tons per year and 645 employees. And this plant is responsible to produce cold-rolled, galvanized, aluminized, and aluminized products. We started the operation since 2003. So, related to our product capacity, we produce at these two plants a wide dimension range. For example, for hot roller, the thickness, the range starts from 1.2 up to 19 millimeters, with width varying from 700 to 1880 millimeters. For cold rolled thickness, the range starts from 0.4 up to 2 millimeters, with width varying from 750 to 1875 millimeters. For hot dip galvanized product, the thickness range starts from 0.5 millimeters up to 2 millimeters, with width from 900 to 1875 millimeters. And in this case, we are able to produce coating surface in GI, GA, and aluminized products. In the left, in the right side, you can see our process chain. Basically, we start with hot rolled products, and we can have the finished products in cold rolled and also galvanized products. Right. So when we think about the challenge of automotive industry today, we have 5 targets that based on sustainability, enhanced safety performance, affordability, and the global platforms and the geographical production shifts. We can see in the graph, in the right graph, that CO2 emissions are changing very fast in several countries through the regulation, government regulations. And it's when we think about it, we imagine that the weight is one lever in the equation, okay? Because OEMs are facing pressure to reduce the vehicle weight, either directly, such as fuel economy regulations, or through synergic effects, such as car weight influencing powertrain sizes. This forces them to reduce the weight in the structural elements and the automotive parts, and it requires material producers to develop lightweight solution, but affordable cost. So, in this way, R&D, global R&D, Arcelormittal, start a project called the SAE Motion since the 2000 years. This project is a generic steel solution, including boring white, closures, chassis parts, and the seats dedicated to different powertrain types, like internal combustion engines and plug-in hybrid electric vehicle and battery electric vehicle. We have a very type of body structures models, as you can see in the chart. And the SAE Motion is basically a set of steel solutions developed by ArcelorMittal for car makers who wish to create a lighter, safer, and more environmentally friendly vehicles. Okay. So in this project, basically, we use our current portfolio of advanced high-strength steel grades. You can see in the left side here the products available globally, and some of them in Brazil is not possible yet, but we will have in the near future new investment here that will be possible to have other grades in our portfolio. And also we use the emerging grades. In the right side, you can see the emerging grades that are under development in our R&D. With this kind of available products, is possible to use in the SAE Motion project to check how this advanced high-strength steel could bring as a weight reduction, cost reduction, and also improvement of safety. Okay. Here I bring an example of SAE Motion mid-size sedan with the material distribution. We have around 56% of advanced high-strength steel usage. I would like to highlight our PHS material that concentrating the brand name Usibor 100 and our Ductibor material. I put here in this chart the Brazil flag just to show you guys the products that we have available right now in Brazil. Here, I would like to highlight a little bit about the press hardened steel products. Basically, we have the Ductibor and Usibor, as I told you in the previous slide. Ductibor is a product that has the basic function of cushioning the impact in case of crash, and Usibor with 1500 megapascal as resistance, used for anti-intrusion properties. Okay, in Brazil, I would like to highlight Usibor 1500. It's available right now in our local portfolio. And this beginning of the year, we started the Usibor 2000 qualification with a local product in Brazil. Okay, we hope very soon to have in the beginning available in the beginning of next year the Ductibor 1000. Okay. So since 2011, ArcelorMittal has been developing steel solutions for electrified vehicles. We have numerous steel solutions developed and supporting automotive electrification. And ArcelorMittal participates to battery pack developments thanks to a suite table of steel grades. Okay, our R&D is working on it since the beginning of the companies start to talk about electrification, and to have the compromises with the right steel in the right place to attend the electrification. So this is as a next step. I would like to left this message for you guys. We are ready to implement and adapt our SE motion solutions into a car maker concept by considering its specific constraints and the material strategy in the framework of co-engineering project. I would like to invite you to visit our 3D car configuration to explore our best-in-class steel solutions. Right? Oh, so I would like to thank you so much for the opportunity. This is my contact that you can exchange ideas with me, and also to check in details our advanced high-strength steel portfolio. Okay, thank you so much, Garbin.
Great, Alexandre. Thank you so much for your presentation. It's nice to the people double check the QR code just to connect to you if you have some more questions. But again, in the end of this panel, we will have a section for question and answers. It will be an opportunity to talk to the presenters. So thank you so much, Alexandre. Right now, I'd like to invite Mr. Richard Rohring. He is the head of policy and external affairs of UK Steel. Richard is he is located in London, the representative body of the UK Steel producing sector. On this role, Richard looks after the organizational relationship with the government overseas and develops sectors, policy, and regulations positions. Richard has worked in the steel sector for 7 years. Prior to this work, the similar role is everywhere in the manufacturing. Hello, Richard. How are you today, man?
Hello, Leandro. Thank you very much.
Great. So you can start to share your screen, and good luck for our presentation.
Fantastic. Hopefully that's working.
Yes, it's working, man.
Grand. Well, I'll just start off by saying thank you very much both to SAE and for DIT for organising this event and inviting us along to present. So DIT asked us to give us an overview of the UK steel sector as a whole, which obviously includes Tata Steel. So I won't be going into technical specifics, but really just trying to give an overview of what the steel sector is like in the UK, what companies operate there, a broad overview of the products that they produce, and a bit of a flavour of the kind of trade dynamics between the UK and Brazil as things stand. So just to start off then, so the UK steel industry is an export-focused industry. It exports just under half of everything it produces each year. Unsurprisingly, for reasons of geography, if nothing else, half of the UK production, which is around 3.5 million tonnes, is exported to the EU. The next biggest markets after that are the US and Turkey, which by value represent about 8% and 4% of our exports. And Brazil, it's obviously a small export market in comparison to countries like the EU and the US, but it is still in the top 10 of our export markets and an important market, and importantly in a market that many UK steel companies see as a growth market in the future. So in terms of actually what we're sending back and forth to each other, there is certainly in terms of volume of steel trade, there is a trade deficit between the UK and Brazil, with us sending just 17,000 tonnes of steel to Brazil in 2019, whereas Brazilian steel producers are sending just over 100,000 tonnes back to the UK. It's a bit more even when we look in terms of value, which is an indication of the products that we are sending to Brazil tend to be of a higher value than perhaps the products that are coming from Brazil to the UK. And that's, I mean, there's an indication that Brazil are sending a significant quantity of semi-finished products to the UK, but also a large quantity of flat products as well, which are obviously particularly important to the automotive industry. The UK's exports to the EU, to Brazil are more heavily focused on long products, but in terms of value, there is a significant quantity of tube products going to Brazil as well. This is perhaps a slightly confusing slide, but it just gives a flavour of actually what the UK steel demand is by both consuming sector and also by products. So in terms of sector, unsurprisingly, demand is dominated by the construction sector, which accounts for nearly 60% of demand in the UK. And other key sectors, notably automotive, which accounts for just under 8% of our steel demand, along with machinery and engineering, just under 6%. Construction is met probably about half and half between domestic supply and imports. And if we look at automotive, which is clearly the key interest for most people on this webinar, we are slightly more reliant on imports for the automotive sector, with them perhaps making up around 60 to 70% of the requirements of the UK automotive sector, compared to 30 to 40%, which is supplied from domestic industry. Looking over at products that are actually supplied into the UK markets, it's dominated again by the top two products are flat products, of coated products, and hot rolled coil, followed by a significant selection of products dominating the construction sector, which includes obviously heavy sections and rebar. Moving on into just a flavour of the steel production in the UK. The steel sector is pretty condensed within the UK. It's dominated by 5 or 6 companies. It has seen quite a significant amount of change, perhaps in the last 4 or 5 years, certainly up until 2016. Tata Steel would have accounted for perhaps 80% of the steel production, but we've seen a significant amount of fragmentation and restructuring within the sector over the last 3 or 4 years. And now we have perhaps slightly more even distribution between 6 companies. So Tata Steel, which has obviously already been touched upon in the first presentation, Tata Steel within the UK produces predominantly in Wales, on flat products. They have a capacity of 4.5 million tonnes a year, 8,500 employees, and a significant range of products from hot rolled to cold rolled, galvanised, tin plates, and electrical steels. The other blast furnace operation in the UK is British Steel, which operates in Scunthorpe. They're concentrating on long products. We have Liberty Steel, Ottacompu and Sheffield Forgemasters are all based in Sheffield, in the north of England. They are producing, Liberty are producing a range of long products, but also some highly specialised products going into the automotive and aerospace sector. And finally, also based in Wales, we have Cesar Steel, who are based in Cardiff and focused predominantly on long products going into the construction sector. I don't mean to dwell too much on this slide, but it gives a flavour of the distribution of what we would term as downstream processes within the UK. So not the primary steel production sites, but the re-rolling, coating, and further working of steel products. So there's a significant cluster of long products businesses. Flats tend to be focused, as noted before, in Wales around Tata Steel. Tube products are dotted around both the north of England, the Midlands, and in Wales. And then we have some forging and casting abilities, most notably Sheffield Forgemasters, obviously based in Sheffield. So just to give a bit more detail on the main manufacturers of steel in the UK. So British Steel manufactures 3 million tonnes of steel each year via a blast furnace. They're supplying to global markets for their manufacturing facilities in the UK as well as in the Netherlands. And they have an annual turnover of 1.6 billion, employing just under 4,000 people. And as some of you may have heard, there was a takeover by a major Chinese steel producer, Yingye, almost exactly a year ago today. Their primary products, as noted briefly before, rail, predominantly supplying the British and EU markets, is a significant product capability for them. Structural sections, again, typically focused most intently on the UK and European markets. Special profiles, which are produced in Skinning Grove and are going into a range of different sectors, including shipbuilding, forklifts and yellow goods. And finally, wire rod, which operates both out of the UK, but also a wire rod mill in the Netherlands. Cesar Steel, based in Cardiff, as noted before, they have just under 2,000 employees based in the UK, an annual production of about 1 million tonnes. The background is they've been operating in the UK for almost 20 years, and they are a Spanish-based company with operations all over the EU. Core products are rebar, wire rod sections, and merchant bar. They produce via electric arc furnace, obviously using scrap sourced within the UK, with a very much a core company focus on becoming zero carbon, in line with the UK's zero carbon targets. Liberty Steel, focused predominantly around Sheffield and the West Midlands, an annual production of 3 million tonnes a year, 3,000 employees. I think probably the most important thing to note on within the context of this presentation and this webinar is the speciality products which they produce in Sheffield and Rotherham. So specialist alloy steel for engineering components, landing gears, controls, aerostructures and helicopter powertrains. They also have a further range, more standard range of products, including rebar, plates, merchant bar, light sections, and a range of tube products. There is one producer of stainless products within the UK, which is Ottacompu Stainless, which is the largest manufacturer of stainless products in the world. Again, they're based in Sheffield with a capacity of 250,000 tonnes of steel a year, employing 450 people. And they will offer a wide range of stainless products that are able to operate in the most demanding of applications. They have an extensive knowledge of the use of stainless steels, both in construction, road and transport, but also in automotive and in engineering components. Sheffield Forge Masters, which again based in Sheffield, are a vertically integrated steel supplier. So they do produce more basic products, but they have a real specialist in casting and forging solutions for some very complex engineering challenges. Perhaps most notably and most relevantly within the energy sectors, so supplying an awful lot of specialist forgings and castings into the nuclear and the nuclear energy industry, but also increasingly the offshore wind energy industry, but also some highly complex components going into the defence industry. Finally, and I won't dwell too much on this because you've obviously heard a very informative presentation from Tata Steel already. Tata Steel obviously operates both in the Netherlands and in the UK. In the UK, it has a turnover of over 2 billion. It employs 8,000 employees, so by far the largest employer within the UK steel industry. It has a range of products just in terms of its key markets, 10% in terms of revenue going into the packaging sector within the UK, 35% going into automotive, so a really important sector for Tata in the UK, and 30% going into construction. I will send these slides so that any of the participants can have a look. Just some further information. So UK government report, a very detailed report on the capabilities of the UK steel sector can be found at that link, which was produced a couple of years ago and really goes into an awful lot of detail about the precise capabilities and capacities within the UK steel sector. UK Steel, my organisation, also has a publication which details further details about where we produce steel in the UK and those products, and also those links that I provided there give further information about the product ranges of each of those core companies that are operating within the UK.
Great, Richard, great. So we are exactly on British time. We are exactly on British time. Really nice, really nice. Thank you so much for your presentation. Really interesting. So right now I'd like to ask Bashan and Alexandre just to open your camera, just to restart our section of Q&A, questions and answers. So I really apologize, but we have a special attendance over here, my little son. So I just would like to start this. Ok, só minutinho, já vou lá, tá bom? Só minutinho. I'd like just to start the first question for Bashan, that it was, could you please just stop to share your screen, Richard? It will be better for us just to see everyone over here on the screen. Richard? Great, great. Thank you so much, Richard. Thanks so much, man. And open your camera. So, Bashan, as I told you, it's really interesting, your subject. As I told you, I already have worked with crash tests, and they're really, really interesting. And for the first question, I just would like to know what factors make crash management for the EV, for electrical vehicles, different compared to ICE, internal combustion engine vehicle. What's the difference between the both one?
Well, indeed, there are a few differences. An ICE powered vehicle is, of course, designed in a different way, and it also has different characteristics. So if you move from that reference to an EV, then of course the vehicle itself is much heavier, because if you look at the battery weight, it's a few hundred kilos. That is somewhere in the vehicle. If you have a mid-range vehicle, the vehicle is a few hundred kilos heavier, which means that if you crash it into a object, either a car or a tree or something else, of course, that crash absorption needs to happen in the proper way. And for this, you need to adapt, of course, the vehicle structure. Then if you look at front, it's also a front module that has a smaller engine or no engine at all, which is, of course, the case in an EV. The engine can be sometimes located even in the wheels. And of course, that also plays a role. The engine itself also is playing a role in the crash management. And the third aspect is, of course, the battery, which is mostly located underneath the vehicle. and it should be kept absolutely safe with no penetration whatsoever, because of course you could regard the battery also to be a bit of a bomb under your feet. And if you don't deal with that properly, of course, it can be dangerous. And that means that also on the side impact, you need to do special things to allow the crash management to be at the right level. You're on mute, I think, Leandro.
Great. Right now it's working, no?
Yes.
Super, super. So I just take care about my little son over here, but right now it's fixed.
It's okay.
So just to continue on this subject that again I really enjoy to talk about advanced high strength steel. One question for you, Alexandre. For example, is it possible to implement advanced high strength steel AHSS, so advanced high strength steel, in the projects that are already in production, for example? So the company is already doing something, already doing the out tooling, it's already prepared for normal steel, how can I tell you? But is it possible to implement this advanced in the current production, for example?
Oh, good question, Leandro. We have facing some regulations changes in South America, like, for example, regulation for crash management that impose for some crash tests with a high level of safety performance. And due to that, some vehicles that already are in place in the market needs to be improved to achieve stars. For example, a TN cap, as I want to talk. And because of that, it's possible. The question is, it's possible to put advanced high strength steel, but of course that we must to do a business case to check the benefits to change for advanced high strength steel grades like press hardened steel, compared with the needs of implementing reinforcement in the body structure. Okay, and then we need to check all investment involved to see if the proposal with advanced high strength steel is more affordable cost or not, compared with the reinforcement that they want to put. Okay.
Great, great. I appreciate. Richard, we have a question over here from the audience. So Mr. Erwin Franiak, he is just asking you, do you see the correlation of production, the advanced steel in UK, and the competitiveness of the industry?
Sorry, so the question is there a correlation between the competitiveness of the UK industry and its production levels?
I see. So depends on the case, you mean?
Sorry, I was just trying to ascertain what precisely the question was. Is the question, is there a correlation between levels of production in the UK and its competitiveness?
Yes. He really would like, as I understood, if you would like to explain over here, even Erwin, I appreciate, but as I understood, he really would like to understand the competitiveness, so between the advanced steel in UK, of course, and how competitive is the advanced high strength steel, for example, comparing to the others one?
If you're looking for comments specifically on advanced high strength steels that are produced in the UK, I would probably refer you to my colleague from Tata Steel, who have a much better understanding of the particular products. In terms of competitiveness of the UK industry itself, it is obviously a highly import intensive market, and it's a very export focused market, so it has no choice but to be competitive, both in terms of costs, but also in its product offering. But yeah, I would have to refer you perhaps to Tata for any specific comments on product specificities.
Would you like to complement, Bashan? Would you like to complement that question about how is the competitiveness about the high strength steel?
Well, I think in general, if you look at the the reason why these steel grades are being developed is that they actually generate a lot of value in the designs of the vehicles. So, of course, because of legislation, if you look at CO2 emissions of the vehicle, basically in the use phase still, of course, lightweighting is very important, and lightweighting is also required, and hence people are able to actually to spend a bit of money in terms of making that car lighter. In our experience, that means that these very special steel grades that are suitable for lightweighting are also able to travel. And if you have locations near harbors, like Tata Steel has in the UK, it is often really easy to actually be able to make a cost-competitive offering, not only for the local market, but also for markets in other parts of the world, like Brazil, because there is so much value inherently in these products.
I see, I see. On the same line, Alexandre, what do you think about the future, about the advanced high-strength steel, and of course about the ultra-high-strength steel? Do you can see some modifications? Do you see some research and development to improve that kind of behavior?
Yeah, good question. What we see is that R&D is preparing, of course, the advanced high-strength steel grades to fit the needs of the electrification vehicles that are coming. But I believe that we will have space for all type of material to be used in the body in white and also in the car components. And we especially for R&D, Arcelormittal, we are prepared to supply materials for battery pack, for example, and to achieve the safety performance when we have the crash simulations and so on. Okay.
I see. Thank you so much.
Thank you.
For you, Richard, what's the key barriers, for example, to increase the UK export of the steel to Brazil? Could you please explain us better about this kind of barriers that we have nowadays?
Yes, of course. Well, I mean, as I showed on my presentation earlier, there is a trade imbalance or a deficit between the UK and Brazil, and some of that, certainly not all of it by any stretch of the imagination, but some of it is down to some barriers that either perceived or real. So I guess the most important one would be the high import tariffs that Brazil has in place, which for steel products range between from 0 but up to 14%, an average of around 10%. So that they perhaps have less of an impact on perhaps your more specialist products that are going into Brazil, but certainly for lower cost products, that 10% import tariff is obviously a really key barrier. Now, clearly, the EU is in the final stages of that Mercosur agreement, which should get rid of ultimately those tariffs and will open up more opportunities. Obviously, the UK has made the decision that not to be party to part of that, and hopefully at some point we will be party to an agreement with Mercosur, but we will obviously be behind the EU in that regard. So that will be a longer term barrier for the UK compared to the EU. There is also some further barriers. The relative weakness of the Brazilian currency. It's dropped 50% over the last 4 years compared to the pound. So that obviously does make steel going into Brazil from the UK relatively more expensive than perhaps its domestic providers. There is also a perception of more complicated regulation. Brazil has been ranked 124th in terms of 200 countries for ease of doing business compared to 8th in the UK. So it is more complicated for UK steel producers to supply into Brazil. And the comments have been made, if you have people on the ground in Brazil and agents doing the work for you, it is pretty much impossible to kind of make that market penetration.
I see. Great. Thanks for your answer. So let's just try to go to the last question from the audience. So Bashan, Leonardo, I have a question for you. So he has a question for you. How do you see the future of the ICE? Do you believe they will remain relevant in the next 30 years?
Well, the speed of the transition will, of course, be different in different regions. I think we all recognize this. I do believe that the global trend is away from the ICE-powered vehicle. We see already some examples, especially in Europe, where countries, but also companies, are taking responsibility and saying, we don't want to have ICE-powered vehicles anymore on the roads, or at least in the sales, after 2030, for example. And it's both companies as well as governments who take that step. And I think that will eventually lead to a bit of a effect that worldwide, this is going to be the trend that in the end, all countries will follow. So if you look 30 years ahead, I would indeed believe that most of the ICEs will be faded out.
Great. Great, I appreciate. Thank you so much. So about everyone, I already included the contacts over here in the end of the presentation. Some other question, please try to connect directly to the presenters. Again, Richard, Alexandre, and Bashan, thank you so much for your presentation. So people, let's right now, we will have a 5 minutes pause just to have a little break for the next section that we will talk about aluminum, okay? Just 5 minutes. Thank you so much.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye
Thank
now.
you.
Excelente, pessoal. So, just to come back from the 5 minutes pause, just to have a little break, just for a coffee drinking in the restroom. So, hello, Savani. How are you today, man? You are on mute. You are on mute. So, gentlemen, Mr. Sergio Savani, he works to SAE Brazil. Great. You just turn off the camera. So, gentlemen, right now, ladies and gentlemen, not just a gentleman, of course, ladies. And on this panel, we will have a lady. Great, really good. Right now, we will start the aluminum panel. It's another material that I really like so much. It's really interesting, the applications for lightweight design and some others applications. For the first presentation, I'd like to invite Mr. Ayrton Filetti, and he is the President Emeritus of ABAL. He will talk about the strategic metal for the mobility industry. Mr. Filetti, are you there? Great. I can see you.
Okay, good.
I can see you and heard you too.
Okay.
Okay, great. So, Mr. You can start your screen to share your screen, and just to talk a little bit about Mr. Filetti. He is metallurgical engineer, over 45 years in the aluminium industry over here in Brazil, and he is the Brazilian Aluminum Association Emeritus President. Okay, and even superintendent of the Brazilian Technical Standards Association. Mr. Filetti, you can start your presentation.
Just open my presentation.
Please.
Just a second.
So, Sergio, if you'd like to turn off your camera, Sergio Savani. Sergio Savani, just turn off your camera. Yes, great, I appreciate.
Não está aparecendo nada, viu? Pronto, agora, o que eu faço? Põe a setinha para cima.
Yes.
Área de trabalho. E agora? E agora?
Great, we can see your screen. We can see your screen. Just open the presentation. We can see your screen. It's okay.
Yes, I am open. Pode agora, põe uma na play.
Pode abrir sua apresentação.
Estou abrindo. Ele está vendo?
Estamos vendo.
Slideshow.
Isso, pode colocar em modo apresentação.
Slideshow. View show.
View show, great.
Great.
Pode ir adiante.
Tá pronto. Tá bom, tchau. Okay, thanks so much. Sorry for the delay. First of all, on behalf of Brazil Aluminum Association, I would like to thank so much for the invitation to participate in this very, very nice session of the SAE. And we are talking about a strategic metal for the aluminum industry. And Brazilian Aluminum, we talk about Brazilian Aluminum Association, the aluminum itself, and also automotive aluminum. That's an important part of the solution. That's the discussion that we have this morning. In terms of Brazilian Aluminum Association, Brazilian Aluminum Association is a class entity that represents all links in the aluminum production chain, including, of course, the semi-finished product downstream, and represents all the components from the mining down to the semi-finished products, of course, also including recycling. That's a very important part of the process of aluminum. Recycling is very important. Those are the associates. There are something like 28 companies. So, which are the main objectives of the Aluminum Association. Aluminum Association works with technical committees to carry out all the development activities to promote aluminum and disseminate technology, incentivate education, research and technology innovation, mainly in the academic side, as aluminum is not very well known metal, by far of steel that's very low for centuries. It's forced competitiveness within the industry, forced health, safe environment standard, very important. And this is a very important point that is, I would say, for ABAO is the most important industry statistic publisher. It represents all the information that's sent to Brazilian government, and the Brazilian government use those information published by Brazilian Aluminum Association. And also have an important mission, draw up and disseminate technical standards for aluminum and be the voice of the industry in all the government levels. Aluminum, strategic metal for various segments and applications. There is no, it's a very important phrase, there is no modern and sustainable society without aluminum. One very important application is energy, conductivity of energy. In the past, all of the conductors are used to be copper. Now is aluminum for high tension electric transportation, because it's very light. Aluminum is just 2.7 grams per cubic centimeter of density compared to steel that's 7.3 and the copper 8.2. So aluminum is very, very light compared with those important metals. And also we have several types of alloys that we can reach important mechanical resistance. Of course, electricity, the conductivity is very important. Aluminum is the best conductor, of course, is copper, but aluminum is about 70% of the copper conductivity. It's a very good thermal and electricity conductor. And a very important business is packaging. Packaging is important. All packaging, that medical packaging, is aluminum in order to preserve shelf life, avoid the oxygen penetration, air penetration, and the safe food. This Tetra Pak packaging has aluminum that avoid the penetration of oxygen, light, etc., and preserve better the product. And another important point is recycling in this packaging. That's very important example is the used beverage can that is recycling. 98% of all the beverage can produced in Brazil are recycled today. That's very important supply of metal for the aluminum chain. Consumer durable, versatility, practicability, innovation. Don't forget it. We have bikes using aluminum. The case of the cellular phone is aluminum. So there is a lot of innovation on this side. And of course, the very old pots and pans of aluminum, very common in our kitchen. This is a very important application, building and construction. Windows and doors and the structure for building, because this is very important because aluminum is a non-rust material. Aluminum has a very thin layer of oxide aluminum protecting the entire of aluminum. So avoid rust, avoid oxidation. So keep their appearance for a long time. That's very important for the windows and construction. Durability, sustainability, and modernity. Beautiful buildings are using aluminum very well. By the way, the sorry. By the way, the IMB has about 400,000 of aluminum for this construction. All the structure and the roof are aluminum. And in transport, of course, this is very important for aluminum today. This is the fox of aluminum industry transport. Why? The car, the trucks might be have less weight, less consumption, less emission, less CO2 emission, and safety. This is an idea about the main markets and global demand for transformed aluminum products, semi-finished products. You see that in the world, transport is the biggest share of the aluminum consumption, followed by building and construction, packaging, electricity, machine and equipment, consumer durable, and others. So there is an annual growth rate from 2016 up to 2001 of about transport 6%. That's very important. And in the left side, you can see the world total production of the world is about 90 billion tons of aluminum. By far, steel is the biggest metal. Steel is about 1,700 million tons per year, more than 100 times aluminum. But aluminum is there. And here, in Brazil, that is, you can see that the main use is packaging due to the beverage can. That's very popular in Brazil. And the second market is transport. And so this will give you an idea about the main consumption of aluminum in the Brazilian market. And the production is there, 1,048,850,600 tons of aluminum. So in the semi-finished product, you can see that sheet is the most important production. Extruded is a process that we don't have this in the steel company. Is a special process to perform the aluminum. Wire and cables, casting is important. Foil is a thin sheet is foil in destructive use, mainly for deoxidized steel. Automotive, important solution for automotive production. So, which are the main advantages of the aluminum in the auto industry? Lightweight, as I have already mentioned, efficiency, cost effectiveness, sustainability, CO2 emission, much less, safety and durability. Aluminum does not rust. Outstanding in various solutions. The trend is of cars, electrification, autonomous vehicles, shared mobility, micro-mobility, low-carbon products, servitization. You can see that you can see the gasoline, diesel, hybrid, electric vehicles. The chart proposed to show that the aluminum, even taking into account the trend of hybrid and electric vehicle, the aluminum will increase the participation. Of course, cast iron and standard steel and the HSS is the predominant material for the car industry, but aluminum is there. And the consistent growth in light vehicle. You can see that the number of light vehicle is increasing year per year. And also the aluminum content is increasing. You can see the CAGR growing from 2016 to 2020, 6%, and from 2020 to 2030, 4%. The most important products are extruded and sheet to use in the auto body sorry, in the auto body car. Okay, auto body sheets for the car is a sheet, but by far casting is the most important part that is in the engines. There is a problem in Brazil. We don't have a specific legislation like in Europe and the United States about the CO2 per kilometer. We don't have this so far, but we are trying to implement this program that was issued by the Brazilian legislation. We call Rota 30 program, Route to 2030 program. There are three pillars. Are mandatory requirements for vehicle. Mandatory. This is mandatory. Energy efficiency and the vehicle safety goals. OEMs and for all OEM and importers, and will be measured from 2002. So that we impose some limits on that. The pillar 2 for automotive chain incentives based on corporate income tax. In Brazil is Imposto de Renda sobre Pessoa Jurídica. This is optional. We can have tax credits on expenditures in R&D in Brazil. 10.2% up to 12.5%. Every company in the automotive chain that carry out R&D, OEM, and auto parts and systems are elected for that. This will be implemented from December 18 till November 23. The pillar 3, research of promotion for the promotion of R&D in the automotive chain. This is optional also. Grants for the execution R&D projects, OEM, auto parts, systems, science and technology institutions and universities are the main people involved in that. This will happen from June 19 to December 23. All those things will be happening and till year 2030.
Mr. Filetti?
Yes, please.
I appreciate if you move to the end for the presentation for the time, please.
Okay, I got time. My time is finished.
Yes, but you can finish, please.
Okay. I'll go fast. That's aluminum technology, sustainability and innovation. This is I passed this slide. This is one thing that's very important is this manifesto of Brazilian aluminum for a sustainable future. Is a compromise. Come back to the other slide. Is a compromise. Sorry. Is a compromise to be online with sustainability projects. Now I have just a final slide is to show what we are doing with Embrapa. Embrapa is an entity, is a company that reports to the Minister of Industry and Commerce that is fostering this project for the R&D. And we are developing a system to develop for a comparison of different joints use aluminum for automotive structures. And BAU is articulating this project. IPT is a very important technological research institute in Brazil. Will carry out, and all those companies will participate in this development. We are put a lot of efforts in have this be implemented. This will be startup for new projects with this important company, Embrapa. aluminum guarantee innovative, and sustainable solution. The Brazilian market offers growth potential for automotive aluminum. Competition, cooperation to compete is an interesting, promising way to boost development, innovation, and competitiveness. I think this, I finished, and thank you, and sorry for delay.
No, it's okay. It's okay. Thank you so much, Mr. Filetti. Very well known entity over here in Brazil. About it's very respected over here. And your history at this association, it's really, really important. Thank you so much, Mr. Filetti. Thank you so much. So right now, I'd like to invite the lady, Mrs. Natalie Yoko Yoshiro from CBA. She will talk about high-strength aluminum solution in the future of the automotive market. Natalie, she is the head of the market development and innovation. She is graduating administration bachelor at Mackenzie University over here in Brazil, and even she took MBA at the University of São Paulo. She has over 30 years of experience in the areas of innovation, sales, marketing, strategy planning in Brazil and the US too, in services, consulting, and industry sectors at the global companies. Hello, Natalie, are you there? You are on mute.
Yes.
Great. Now I can see you. I can see you, and even I can hear you. How are you today?
I'm great, and you?
Great, great. Thank you so much. You're welcome. And please, you can start your presentation. I can see, and even I can see your screen and heard you really well.
Okay. So, hello, good morning, and good afternoon. It's a huge pleasure to be with you today. I'm Natalie Yoshino, and I work as market development and innovation at CBA, one of the leader companies in aluminum production in Americas. So firstly, I'd like to thank to ASE to the opportunity to share a brief presentation about our readiness for the automotive market. And well, we'll share some developments for structural components with high strength aluminum alloys. So to start, let me introduce very briefly about our company strategy and how we co-create with our customers. So CBA is an investee by Votorantim, an investment holding company with 100 years of existence. So these are the investees, and we are very proud to belong to such important economic sectors. And currently we are present in 20 countries, mainly in basic industries and financial sectors here, as you can see on the end of the chart. So Votorantim covers the following industrial markets: cement here, polymetallic like zinc and copper, aluminium here, long steel, energy, and orange juice. Well, here I'd like to emphasize our purpose, that is to provide aluminium solutions that transform people's lives. Besides all that, I'm proud to share that as the aluminium producer with one of the lowest emission index in the world, CBA became the first company in the Americas to be an ASI certified company and one of the world top 10 in standard and chains of custody scope certification. And also, CBA adheres to the Global Compact, as well as we are committed to setting a science-based target. It means that CBA is in line with what is required by most ambitious goals of the Paris Agreement. So, what about CBA in automotive market? Well, I'm going to mention about CBA's product very briefly because we provide a wide range of products, including ingots, billets, sheet rolls, foils, extruded profiles, and engineered projects. As we have a very short time today, I'll focus the presentation on extrusion products, our main solution to the automotive market, okay? So, for me, extruded profiles means freedom. You will understand what I'm saying because this product is very, very customizable for each kind of need, market demand, or end users' behaviors. I'm speaking of co-engineering by translating value proposition through that. Well, we are aware that automotive aluminizing growth is fresh and beginning in Brazil, and therefore it's followed by a lot of opportunities. And to ensure our readiness to the market, our project managers from Innovation and Market Development team, we co-create with value chain players, our direct customers like auto parts, producers like body in white or chassis, OEMs, our suppliers, of course, end users, and others whom may contribute. And it means to understand deeply the challenge of our customer, address their pain points beyond the aluminum material itself. And third, CBA aims to bring overall savings and efficiency gains to the whole ecosystem, helping customers to produce more lightweight, durable, and sustainable products. So, as I said, demand for aluminum in the automotive industry is continuing its growth path. So automakers have to evaluate constantly a number of factors to determine the best materials for their vehicles. Therefore, we foresee a multi-material approach emerging more and more as different vehicles models have come out. As this approach evolves, it is one of I would say the main factors driving aluminum increased market penetration as well. The distribution is quite concentrated here in casting and chip products, but we foresee an increasing employment for extruded profiles. So let's have a look at the next chart so I can give you more details about that. Well, as you can see, even if aluminum should lose market share in some application areas, it will find increasing employment in others, and its growth areas will remain larger than the areas in which substitutes are found. I will highlight here. It happens because there is a content trade-off in switching from traditional IC engine to electric motor, since various powertrain, transmissions, and driveline components are removed. So, however, this scenario is counterbalanced by the implementation of electric powertrains and platform components, including motor housings, battery frames, and as well as the closure and body platform components. That's why, as a result, we believe that the aluminum participation for specific electric vehicles components is added back in. And matter of fact, we believe that the major growth in the electric vehicle market will be expected to see in aluminum extrusion sheets and structural castings. And it's important to stress that the average BEVs made in North America nowadays has almost 3 times as much extrusions than the average conventional powertrain vehicle. And also aluminum participation that has been historically relevant in secondary casting tend to be replaced by aluminum in more engineered products. So speaking about Brazilian scenario, I'll start by US. Because in the US, aluminum in automotive started 10 years earlier than Brazil with heat exchangers. This 10-year gap is mostly due to a past with no regulations, as Ayrton shared with us, and subsidies to control these emissions. So a government program called Rota 2030, this 2030 route, came into effect at the end of 2018 and consists in a set of subsidies for the auto industry to boost local development of technology. And moreover, CBA is conducting some initiatives for this program that I will share with you in the next charts. So we believe the gap is closing increasingly, and we have a great opportunities, for example, in crash management systems, cross members, etc. And in long-term perspective, we also see a lot of opportunities in the adoption of additive manufacturing. So let's focus on the structural components here. We emphasize developments in this extrusion for this application. So I will share and play a 1-minute video with some possibilities, and I'll be right back. Well, you might be asking themselves, why extrusion? Well, I believe that unlike other formings and shaping processes, the aluminum extrusion technology enables the productions of shapes in fairly complex geometries and in a single operation. As a result, the designer is able to position the metal allocation where it is most effective. For example, the bending strength of a profile can be increased by concentrating weight away from the center of gravity, for example, or a component that would probably be made with welding things onto a steel tube. It can be directly extruded in one single part. So you can also combine complementary functions while at the same time saving weight. So you can increase the stiffness of the structure or facilitate assembly operations or even reduce the required amounts of machining. And another day, I was in a meeting with a partner and he asked me about how feasible is the use of aluminum extrusion for battery frames once there is a relevant variety of sizes and shapes being developed. And he was concerned about these low volumes fragmented in a range of specific features and for sure the initial investment in tool development. So I answered that compared to stamping tools laid out for steel, extrusion tools are modest in price, around 5% of the stamping investment. That makes aluminum extrusion a very attractive solution, even for a low volume production. And the production lead time do not run over 15 days for these tools. So shortens the time required to, for example, marketing launches. Speaking about prototyping, the whole manufacturing and production process starts with the design. In the design phase, extrusions take shapes and features are built in to enhance this customer performance required. From then, our team can validate the model through computer simulations and make adjustments like testing a fitting, a plug-in into the prototype made, for example, with our 3D printer. So the prototyping shortens the development process and reduces the initial cost and risks. So CBA truly believes in fail fast and fail small methodology. All these steps increases the likelihood of a successful design that meets both performance requirements and lightweighting goals. The next chart. Well, this is a question that I get asked a lot, is about the availability of high-strength alloys production in Brazil for aluminum extrusion. So both 6,000 series alloys and 7,000 series alloys can be perfectly incorporated in many structural components. And it's important to emphasize that both alloys are heat treatable for the purpose of increasing corrosion resistance, hardness, or strength. And yes, answering the question, taking the opportunity to answer this question, CBA has brought readiness to Brazilian market in terms of these special high-strength alloys and we undertake continuous investment development in this sense. So let's check a few cases of structural components in the next charts. Well, this component is produced here and helps to improve handling and steering while increasing platform rigidity. But also contribute to vehicle lightness, which helps fuel efficiency, that is very important. And it's not about MPA grades by itself. Precisely, the optimized shape increases a lot of strength and helps to improve the collision performance by its impact absorption, for example. The next case, this is an example of what I have mentioned about partnership developments, co-creating together with the whole automotive chains among, here you can see institutes, startups, customers, OEMs, and even competitors. So part of the investment comes from Rota 2030 that Ayrton mentioned, the 2030 route program. And the project has intention to arrive at a wide range of applications that meets the objectives of energy efficiency and vehicle safety. And the last study I'd like to share is a partnership with the ESI. We've compared 4 shapes in 2 different aluminum alloys for side door impact beam application. And we used as baseline DP800 steel model. And we considered 2 opposite contexts, a scenario in which the best proposal will be based on the weight in relation to the baseline, and another scenario based on the energy absorption capacity, always comparing to steel. And we chose this scenario so that the result would be allow us to give a better combination of lightness and impact absorption performance. So considering the same weight for aluminum and baseline, aluminum achieved a higher stiffness performance. And in the energy-based study, we got almost 3 times weight reduction compared to steel. And in the weight-based study, the model increased almost 6 times in energy absorption compared to baseline. And in regards of assembly alternatives, we studied huge different types of junction as well as welding and mechanical joint, and obviously considering each OEM processes they use in the process. They use in production. And in my opinion, one of the distinguished highlights was certainly the side impact test. We got an expressive result with a reduction of the rib injury of 1.4 millimeters compared to steel baseline. So we can say that aluminum can save lives. So to conclude my presentation for today, I'd like to share some final thoughts with you. So the mass reduction trends and increased vehicle safety demanded by society challenge all materials to evolve, and definitely CBA is pulling its weight. Due to its wide shape versatility and significant energy absorption capacity, aluminum is the material of the present and the future for structural components application in vehicles. Third, CBA is prepared to be protagonism and support the market increases through stringent high-strength alloys. And CBA is working with and constantly open to partnerships with automotive chains and OEMs in co-engineering projects. This is very important to understand the whole necessity. And the last but not least, these are the drivers to our following objective. CBA aims to be a reference of aluminum solution and service provider for the automotive market in Brazil. So we look forward to talk a little bit more with you during the roundtable. Thank you very much. I think you are mute.
Yes, because I have 2 mute. I have over here on my headset and even over here at the Teams. So I really appreciate. Thank you so much, Natalie. Again, talking about crash, talking about simulation, and I have shared that aluminum can contribute a lot, not just for safety, even for lightweight design. Thank you so much, Natalie. Thank you so much. So, people, right now, I just like to go to the last presentation about the aluminum panel. I really would like to invite Mr. Jan Lukaszewski. He is the technical manager of Aluminum Federation at Alfeed, located in London. Mr. Lukaszewski is a technical manager. The headquarters located in Midlands, the region of UK. Today, he is focused on leading his energy and expertise to fostering research and innovation, best practice skills, and competitive for the UK aluminum industry. Welcome, Mr. Lukaszewski. How are you today? You are on mute, man. You are on mute. No, we can't hear you. Let's just wait a little bit, people.
Right, can you hear me now?
Yes, right now
Right,
we can
thank
hear
you. I'm
you.
sorry.
Well, welcome, man.
Thank you. Right. Well, thank you for my previous two speakers, because the first speaker told me all about aluminium. The second speaker told me how we're going to use it. I represent the aluminium industry in the UK, so I'm a federation. Very much like Brazil, we start off with aluminium out the ground and all the way into the end product. But in the UK, we focus far more on downstream operations and far more on assemblies. As the previous speaker said, it's the metal of the future. And let me throw some numbers at you. In year 2000, there were 20 million tons of primary aluminium produced. Last year, people argue over the number, but it was 60 million tons. Now, please remember, aluminium's a third of the weight of steel, so you have to multiply everything by 3. I'm going to start off by talking a little bit about the aluminium industry. Now, in the UK, we are seeing phenomenal growth. We're replicating what's happening in the thing. In the UK, the aluminium industry turnover is about £10 billion. We add about £1.8 billion to the UK economy, and the whole supply chain, this is including the end products, probably adds about 3.9 billion. We've got 500 active companies in aluminium, and we employ about 22,000 people. The UK total aluminium consumption is about 4 million tonnes, and I'd like you to bear on that number in a few minutes. The two big markets in the UK are automotive, and that's about 30% of the whole aluminium industry. Body in white, crash extrusions. We have a huge amount going into castings and also forgings. We make a lot of aluminium engines, and the growth that we're seeing is in electropropulsion. Now that is crash boxes, cooling, and the actual structures and things like foils into battery. The other big market in the UK is architectural, and then I would drop right down. There's a huge development in power transmission, not only in automotive, where we're knocking copper out on our weight basis, but also in industry and architecture. In terms of the UK automotive industry, and the UK has a roadmap for the development of automotive vehicles, in 5 to 7 years, the industry is working to develop a medium tensile aluminium alloy with a tensile strength of about 500 megapascals. Even today, when we substitute aluminium for steel in electric vehicles, we're achieving about a 14% weight saving, but we need this tensile strength for things like battery boxes. The other big area that we need to see in things is the foils that make electric batteries work. And like the rest of the world, we are recycling aluminium, but we intend to lead that. So within 5 years, we're intending to have about 25% of end of vehicle life scrap back in there. If you move forward to the medium term, we are developing a 750 megapascal steel. So steel boys, please watch out. And we're going to be recycling more and more scrap. And the final objective is, with long term, 10 to 20 years, to have 1,000 megapascal tensile steel, aluminium, which will really maximize the weight saving of automotive and everything else. But we also intend to try and be 100% renewable energy. Where's all this coming from? Well, in the UK, we have 8 universities very actively involved in aluminium. And we've got universities that are forming on alloy development, product development, but also the circular economy, the cradle to cradle of aluminium. we've got a UK catapult, and a UK catapult is a government-funded research body which is specialising, and we work with the Advanced Forming Research Centre in Scotland. They are looking at digitalisation of the industry and also 4.0 technologies, artificial intelligence. And in the UK, we probably have the world's leading university, Brunel, BCAST, which is looking at casting technologies, casting alloys and extrusion innovation. So we are really leading a lot of global research in the process of aluminium. Everyone knows the horrific carbon footprint of aluminium when it comes out the ground. That is not quite correct, because we're a third of the way to steel. So you have to divide those numbers by 3. Best practice in Europe brings the carbon footprint down to somewhere between 4 to 5 tons of carbon dioxide per ton of aluminium. So we are working on decarbonisation, and we're working with Warwick University and local things. We're also actively exploring hydrogen as a fuel gas for aluminium recycling, and we're working with other universities on a circular economy. And today there's a project going on which is looking at recycling 200,000 tons of aluminium packaging, but through carbon neutral smelting and new rolling technologies. So we really are looking at research. If you look at the UK industry, I said that we use 4 million tons. We've got one smelter in the UK, Loch Harbour. It's hydroelectric powered. They produce 50,000 tons. And the UK secondary production, recycled, we have 14 remelt plants. We have about a capacity of 1 million tons. So we import 3 million tons. Big opportunities. We've got a couple of master alloy producers that export across the world. And if you look on the support infrastructure, we've got people that are designing furnaces. We've got people that are developing and selling fluxes, refractory manufacturing, and even dross disposal and research. So we're providing a holistic approach to the whole industry. In the UK, the aluminium, beyond doubt, is the star of the circular economy. This is cradle to cradle. We've seen the numbers from Brazil. They put some of our recycling numbers to shame, but we are still very, very high recyclers. And the UK recycles about 800,000 tons of aluminium out of the million that we produce through that. We actually export 450,000 tons of scrap outside the UK. Now, this scrap is quite important because it's been sorted into grades and or alloys. And given the automotive growth in the UK, we predict that the UK scrap market will be 1.6 million tons. Now, in the UK, we have a completely established sorting infrastructure for scrap, but there's a huge amount of research going on scrap sorting developments, and there are a number of pilot plants being set up to recover drosses. Big market in the UK is castings, and we have 5 automotive engine casting plants, and we've got about 50 casting foundries, and we use all of the technologies. The UK consumes about 400,000 tons of ingot, of which 300,000 tons is sourced within the UK from recycled, but there is a lot of more capacity and more capacity demanded. If you talk in terms of wrought product, we've got 3 melting rolling products plants. The first one is a automotive slab reprocessing plant. So they collect the scrap, they melt it, they purify it, and they produce slab, which is then exported into Europe for rolling into body and white sheet. We have a aerospace remelting and plate mill producing 200,000 tons, which is supplying across the world. and we have a foil litho plant, which is a remelt, hot rolling, cold mill producing foil and litho plate, about 200,000 tons. The big gap we have in the UK is body in white sheet, an investment opportunity. In terms of extrusions, the UK production is about 120,000 tons of a capacity. And we've got a couple of extrusion logs. So these are recycling aluminium for extrusion logs. We've got 11 extrusion plants, but the UK market is 300,000 tons. We produce 120,000. So there's a big shortfall, and there's quite a bit of investment going on in new extrusion plants. Again, an investment opportunity. And BCAST has a pilot extrusion plant, so they have an R&D extrusion research facility. In terms of automotive, in the UK, we have very roughly 20 automotive fabrication assembly plants. These are tier 1, tier 2, tier 3. In the UK, most aluminium is going into Jaguar Land Rover, but also Nissan and Toyota, and there's demand overseas. So our tier 1 companies have capabilities of full design, full manufacture and supply. The big interest in the UK is obviously chassis, body in white, but there's a lot of development going on in battery housings. We have a very well-established distribution infrastructure. We have to import 3 million tons of aluminium. Yes, we export. So we have over 30 independent companies which are providing the import-export distribution infrastructure with over 70 distribution sites. So we are able to import the right grades of aluminium at the right place and distribute them within the UK. In terms of component manufacture, there's a lot of work going on. So in the UK, we have some forges producing high tensile, high stress components. Lot of work going on powder metallurgy. We've got gas manufacturers, we've got coaters, we've got heat treating. So we basically offer the complete support to the manufacturers, tier 1, tier 2, tier 3, across the whole industry. So we are well supported with component manufacture. And the last point I want to make is the growth of aluminium in the UK is matching that of global demand. So as a federation, we welcome new entrants, and we will help new entrants come into the UK aluminium industry with networking, with training, with product development, with process development, with best practice, and with importing. I hope that gives you a good oversight of the aluminium industry.
Mr. Lukaszewski,
Yes.
I appreciate if you move to the end of your presentation, okay?
Right. Are there any questions?
No, we will start the Q&A in the end of your presentation.
Okay.
Okay.
Thank
Please
you. Thank you very much for the opportunity to speak. Thank you.
Great. Great. If you'd like to finalize it, please feel free to finalize the presentation.
In essence, in the UK, because we're seeing such growth, because we are in Europe, we're outside Europe, because we're doing so much research, so much investment, and because of the demand, the UK is basically on the brink of a huge surge in aluminium and in use, not only in automotive, but also in architectural and packaging. So we are more than willing to work and collaborate with people that want to use our research technical support, but also to come into the UK. Thank you very much.
Great, great. Thanks, Mr. Lukaszewski. Is it correct, my pronunciation, Lukaszewski?
It is good. I am
Great.
Jan.
Great, Mr. Lukaszewski. Great, great. Thanks so much. Please, I appreciate if you stop to share your screen. And right now, I'd like to invite Mrs. Natalie and Mr. Filetti just to open your camera to start the section of Q&A, question and answers, please. You can stop to share your screen, Mr. Lukaszewski.
Right. Is that it now?
Great, great. Right
Okay.
now it's working.
Thank you.
Thank you so much. Thanks so much for the Rohring presentation. It was really good. So let's start with the lady one, of course. Let's start the Q&A with the lady one. So Natalie, you showed a really interesting presentation about CBA, about your facilities, about the types of aluminum that you can provide to the market. But how really is CBA as a structural component to provide to the Brazilian market?
Are you listening to me?
Yes, yes.
Okay. So, we prepared our readiness by providing these strength alloys for extrusion available to develop new projects together with our customers. So, the automotive business is one of the CBA strategic pillars. So, we really aim this segment to grow and to foster this market together in Brazil. So, the first of the actions, the main actions we took was to develop this high strength extruded alloys and the co-engineering project together with the value chain. So I consider the readiness of CBA very great and prepared to the next projects it might soon appear.
Great, thanks so much, Natalie. Thanks so much. For you, one question, Mr. Filetti. You told about us for the Route 2030. So it's a Brazilian program for innovations. Is about opinion. So at the association opinion, mind leverage the utilization of the aluminum in the auto industry?
Yes, we believe that about the Brazilian aluminum producers, we have some opportunities on that, because the main goal is to increase the efficiency of the gasoline or diesel. And so you need to have a car lighter than before. And the car lighter means more aluminum. And this is our approach, that this is very important for the aluminum industry. Due to that, is a possibility to increase aluminum in order to achieve the standards to be set by this program.
Great, yes. In fact, weight in the cars, it's not so good. So if you have a lightweight design, you have so many differentials, you have so many good things in terms of fuel economy, in terms of safety. It's really interesting. And on that way, Mr. Lukaszewski, what about the growth opportunity in the UK? What do you think about the aluminum application and the cooperation, of course, between UK and over here in Brazil?
Well, first of all, the growth of of aluminium in UK is such that we need other countries to come and support us. What we are good at is research and development. Our automotive industry is probably world leading with lightweighting, and we're doing more and more work with that. The other big area that in the UK is committed to be carbon neutral with low carbon technologies. So we are very speedily developing low carbon or carbon neutral recycling of aluminium and all those sort of processes. We aim to be at less than 0.5 ton of carbon per ton of aluminium in recycled aluminium. That's our objective. We can export that technology, but the industry in the UK is growing, and we need, there is big investment opportunities in the UK.
Great. So, Natalie, we have a technical questions over here from the audience. I don't know if you could try to answer. The people over here is asking about the lower fatigue strains of the aluminum alloy comparing to the steel influence application. How you see that difference between for the aluminum application and the steel application?
Okay, we actually ran many tests to evaluate these properties of these high-strength alloys and compared to these steel available at the market, and all of them had approved and presented competitiveness if compared to steel.
I see. Great, great. So in fact, even to have a lightweight design, you know, it's really important. And for you, Mr. Filetti, we have another question over here. In terms of cooperation, you showed us so many cooperation that nowadays about it's running over here in Brazil, but there are another projects that you are running, that you are planning, even over here to try, even overseas, to try to have some cooperation in UK?
Yes, this we are quite confident that we can increase this cooperation with Embrapi. By the way, Embrapi, translate to English, is a Brazilian company for research and industrial innovation linked to the Science and Technology Minister of the Brazilian government. So this program, we have a lot of possibilities, and we are encouraging our associates to be in this program with Embrapi. Embrapi is very important participation exactly to, I would say, animate those people to invest in new technology, new development, new process.
Great. Even to try to have some government funding for this kind of research and development. No, it's really important. And for you, Mr. Lukaszewski, what you can tell us about the research into recycling and alternative rolling technologies for this?
We've got a pilot. We've got a feasibility study. Now, traditionally, you take aluminium and you shred it, sort it, remelt it, produce a slab, send it to a hot mill, send it to a cold mill, do it. The research that we're doing on is a complete integrated line. So the idea is we sort the aluminium into alloys, we melt it, we then direct roll it particularly into packaging foil, but there's a huge demand for packaging foil. So that's out where we're at feasibility stages at the moment. There'll be a press announcement later on in this month about a project called Backpack, which is explicitly looking at that research.
Great, great. I appreciate. Let's just go into the last question for you, Nathalie. How could the aluminum industry support the automotive chain to bring more agility and for local solution the structural components applications?
Okay, I think it's working together. There's no other better ways to work together. So that's why I shown in my presentation some examples of how we can co-create together. And thanks to improved joining and processing technologies, car companies do not have to focus on a singular material for the entire car. So rather they aim to utilize the best material for the weight, another for strength, another for performance required for a particular component, for example. And I think we have to think outside of the box. We have to consider the overall savings and the overall legacies to the society. So maybe reducing the number of parts, leading to lower tool and assembly costs, integrating the parts of the whole value chain and working together. I think this is the best way to do.
Do you have, Nathalie, some at CBA, one specific line for aluminum application at the aeronautic market?
We participate in a niche for this segment, so we do not have a specific line for that.
I see. Great, great. So, ladies and gentlemen, again, I really appreciate. Thank you so much to to the very nice presentation, Mr. Lukaszewski, Mr. Filetti, Mrs. Yoshino. Thank you so much, Natalie.
Thank you very
for
much.
the presentation.
Thank you.
And
Thank
right
you.
now, I appreciate. Thank you so much. So right now, I just invite you just to turn off your camera. And so according for the time, we are starting to be a little late. So we really decided over here to jump the pause that we were scheduling. And right now, I just like to start the panel of plastics. So this is the last panel that we will talk about plastics. We will have 2 presentations on that. And the first one, I'd like to invite Mr. Stephen Hunt, and he is the membership of services director at BPF. Stephen, are you there, man? Great. Are you on mute? Okay, so just to talk a little bit about Stephen. Stephen is a membership of services director of the British Plastic Federation, as I told you before. He works over there during 15 years and oversees services offered by federation to its members. The BPF have around 5,000 members who between them represent around 80% of UK plastic industries by turnover. Membership covers raw material producers, processors, machinery manufacturers, and recycling. Great, Stephen. Can you hear us?
There you go. I can. Can you hear me now?
Yes, I can hear you, and even I can see you, man. How are you today?
So I'm very good. I'm very good. Thank you for the introduction there, Leandro. And apologies. After 1 year of doing these kind of things, we should get used to unmuting ourselves. And I apologize.
It's normal. It's our new normal, as we say.
It's the new normal. Very true. Very true.
Go ahead, man.
Okay, no problem. So just one quick thing, I might have added an extra 0 in my email to Leandro. So we've got 500 members. I will explain in terms of who we are in a second. And before I do, just say thank you very much to Douglas Barnes and DIT for inviting me to speak today, and also for Leandro and SAE for holding really what is a
Let's wait. I suppose that Stephen missing the signal. Let's just try to wait a little bit. Can you hear us? Can you hear me, Thais?
Yes, Leandro.
Oh, great, Rodrigo. Thanks. So, in fact, maybe should be some trouble at the Stephen signal. And he just correct me. It's 500 members, not 5,000. Sorry for that.
I am really sorry about that. I am back. If that is...
Okay, you're back, but
sorry, my internet kicked me out. I apologize. It's okay.
Okay, no problem. You start to share their screen, please.
Okay. There you go. So there you go. So apologies for that. Yeah. So in terms of the BPF, so I work for the Trade Association, the British Plastics Federation, and I would say that unlike a number of people today, we are quite broad in terms of what we cover. So I hope what I can do is really give an overview in terms of the size, shape, and dimension of the UK plastics industry, and also try to help in terms of how we can connect the UK plastics industry to Brazil and vice versa. So as a short overview, we are Trade Association. We have about 500 members. Between them, it represents about 80% of the plastics industry by turnover. And our membership covers everything from the raw material suppliers. So this is additive suppliers, master batch, polymer producers and distributors, through to the processors. So people like the injection molders who make the automotive parts, packaging companies, windows, pipes, then to the equipment suppliers, and also the recyclers and waste management companies. So it's quite a broad spread of most of the industry within the UK. And this is how we structure ourselves. So we've got about 32 members of staff. and we look after a variety of different groups that you can see on the left. So we've got 18 different membership groups. The molders are the people who would mold the automotive parts, and then you've got the recyclers, etc. And if anyone is interested afterwards, I can signpost you to the specialists in the various areas and the work that is being done within each of these areas. And we also have a number of central expert committees, and those committees really are looking at the whole industry. So we look at things like fire safety, health and safety, skills and education, which is a big thing for us in our industry at the moment, trying to get young people into the plastics industry with the right relevant level of skills, and we do a lot of work around that. And sustainability, which it's been talked about quite a bit today, I think, in terms of recycling, sustainability, and you can imagine for the plastics industry, that is a really big focus for us at the moment, and something that we are doing a lot of work in. Our sustainability committee was established in 1972, so you can see sustainability isn't new for plastics, but I would say it has got a really more focused area and more work that's being done over the last few years. In terms of signposting to the BPF and its members, this is quite a useful document, I think, for companies over in Brazil, because what this does is we publish it every year, so it's very up to date, and this has the 500 members in the federation, and it's very clearly defined by who they are and what they do. So you can see on the screen there the moulders, and that's got our 100 moulders in the UK, 30 of them supply into automotive, and that's clearly laid out who it is and what kind of materials they process or what kind of processes they do. Same for recyclers, if you're looking for recycled material or additives or master batch, that it's all available within there. And there's a much broader one, which is all we have. I mean, I think I mentioned in a minute, 6,200 companies in the plastics industry. We've got about 2,800 of them on a database. It's open, it's free to use. You can go in there, you can look for plastics companies of all shapes and sizes, and it gives you their members and non-members within the federation. So in terms of the plastics industry in the UK and its kind of size, so we're currently either the second or third, depending on the day really, manufacturing industry by size of employment. So we employ 182,000 people. It's growing. I mean, it was about 150,000 less than a decade ago. So as an industry, we are growing in terms of numbers of people. The turnover is about £27 billion, and we have 6,200 plastics companies. I think unlike other sectors, the plastics industry is made of an awful lot of SMEs, so small and medium-sized enterprises, and actually 98.3% of our industry is SMEs, and I assume that the plastics industry in Brazil is very similar, where lots and lots of small companies really make up the majority of the industry. And we're processing about 3.3 million tons of plastics material here. And if anyone was ever wanting to visit the UK plastics industry, this is what the UK looks like, and this is the location of plastics firms. And one thing I would say, that there is no specific focus. They are dotted all around the UK, and spread quite far and wide, really. They were historically areas of speciality, but really it is quite broad across the UK. In terms of our international trade and where we're dealing with, so about 70% of our trade is with Europe. It was mentioned earlier in the steel presentation that, you know, it's closer to market. That's where most of our market was. But at the same breath, we're exporting 2.8 billion pounds of plastic material to the wider world. 80% of our members export, and plastics is the 9th biggest export from the UK. So you can imagine we're exporting a lot. In terms of Brazil, we're exporting 64 million pounds, 1.8 billion pesos of plastic parts, material and machinery to Brazil, and we're importing 11 million or 318 million pesos into the UK. Quite a lot of exports actually around machinery to Brazil from the UK, specifically ancillary machinery. In terms of the UK industry, and I think it's probably similar numbers to Brazil in terms of that this number here is not the value. What this number is the volume. So of all the plastics that's processed in the UK, 42% goes into packaging, 23% into construction, and 7% into automotive. So automotive is quite a small part, although it's the 3rd biggest consumer of plastics in the UK. Numbers going up for the amount of material that goes into cars in the UK. And by value, it's a lot higher. So whereas packaging is 42% of the industry by volume, it's only 4 billion of a 27 billion pound industry. So automotive is quite a significant chunk in terms of the value within there. To get an idea, there are 144 injection molders in the UK supplying into the automotive sector. And the automotive sector within the UK historically has been quite a driving force in terms of increasing the productivity, increasing the efficiency of companies. And it really, you know, is quite a big chunk of the industry as a whole in terms of machinery, in terms of processors, and in terms of raw material. This number, the best I could find is 2016, but this is the type of material, the type of plastics material that goes into automotive sectors across Europe. I do have some data for the UK as well, which unfortunately I can't share, but it's very similar to this. So you can see within here that this is where we are, and these are the types of plastic raw material by type that goes into automotive. And on the right hand side there you can see where it goes within a vehicle, and it's growing and growing year on year, and I think we're currently on about 15% by weight, about 50% by volume of cars. So in terms of plastics and automotive in the UK, one thing we have, guys, partly because of Brexit, we were doing a lot of work in terms of trying to understand the automotive supply chain within the UK. As I say, it's quite big, you know, with 144 just injection molders supplying in. We have 35. So what we've done is we've set up an automotive group. It's chaired by a guy called Ian Ray from Jaguar Land Rover. It's got various other ones, Honda, Ford, Nissan, all involved in it. And what we were trying to do is understand the supply chain of plastics in the UK, look at what the future of that looks like, and look at what our strengths and weaknesses are in the UK. The people on the right took part. This is the study. The study, I would say, is about a month away from publication, so it'll appear on bpf.co.uk soon. In terms of what happened is we had 8 or 9 meetings. We worked with Cambridge Institute for Manufacturing, and we came up with these 6 strategic themes for plastics and automotive. So really looking at the need to increase the amount of recycled content that goes into cars. They came up with a number of around 20% to be a good number. Look at lightweighting within cars and the role that plastics plays within the lightweighting. Understand the need for the supply chain to better communicate and talk to each other, and what functional plastics there are. So what is the next generation of plastic, looking at thermoplastic composites and things like that, to understand what the direction of travel is for automotive. And a couple of documents just to signpost people to, because the UK plastics industry is very, very focused in terms of a circular economy, sustainability, net zero, carbon neutrality, to try to drive the industry further forward. This is a document we published about 3 years ago, a vision for a plastic circular economy. I think if people on this call are interested in understanding the direction that the industry is going and what actually needs to happen to get to this circular economy for plastics, this is quite a good starting point and looking at the various things that need to be done. We also published 2 documents very recently. This came out in January, the sustainability in the plastic supply chain. There's an interesting case study within there from Jaguar Land Rover, looking at how they're reducing the carbon in cars and how they're using polymer to help them achieve that. So it's a worthwhile document to go into and look into. The other document, which again we published back in January, is a recycling roadmap. So we tried to take a step back really and look at what exactly are we recycling in the UK, what volume are we recycling, and what we really need to be recycling by 2030. There was quite a lot of criticism around the export of plastic waste, something that we, the BPF, have been fighting against for a long time. We have many recyclers in the UK who frankly want to keep the material in the UK. And what we tried to do is look at where we are in 2020, where we would like to be in 2030, and what needs to be achieved to help do that. So I think anyone on the call who's interested in plastics, recycling and sustainability, it's an interesting report and case study to look into in terms of what needs to happen to get. I mean, you can see here we have doubled the amount of recycling in the last decade, nearly trebled it in 14 years. But where do we need to go from that? We need to reduce the amount that goes into landfill to virtually zero. We need to reduce the amount that's exported to recycling, unless it's going to countries that are definitely going to recycle it. And we really also need to look at the non-mechanical recycling tonnages. There's a thing here that took from 5 tons where we are at the moment to 300,000 tons by 2030. And that's really looking at chemical recycling, which I'll touch on in a second. Within the report, I've just said there, it's on page 27. It's an interesting thing within there is we really looked at the recycling of automotive and what needs to happen. And the author of the report actually spent quite a long time trying to understand what value of plastic is currently in cars driving around the roads in the UK. And they calculated that as around 113 billion pesos or 3.8 billion pounds. And understanding there, well, if you understand there is clearly value there, at some point these are reaching the end of life. How do we really maximize the yield from these materials and recycle as much as we can, especially since we are putting somewhere between 450 and 600 kilotons of plastics on the road each year in vehicles. When they come to their end of their life in 15 years' time, how do we capture that? So I think people on the call might find that quite an interesting report into it. And then the last thing here, just talking about just general trends in plastics recycling in the UK and globally. There's an awful lot of looking into this thing, chemical recycling. I just grabbed this book before here, which the BPF published in 1972, which really talked about the future of chemical recycling. So it's been something that has been there for a long time. The technology's been there, but the drivers haven't. And the takeaway is the drivers are there now. So in the UK, we have 16 chemical recycling companies in development working on processes. And what this is taking material back to its virgin properties again, which is really useful in automotive because of the quality of material and the quality of feedstock that's needed. So it's an interesting development. It's still a few years away, but it is a direction that we're looking at and taking quite seriously. You can see quite a bit of information on that website URL you can see in the bottom right-hand corner. And with that is apologies for earlier for dropping out, but those are my contact details. If anyone wants to get in touch, I'd be more than happy to connect with other companies within the UK plastics industry.
Really works pretty well, Stephen. Works pretty well. It's the sounds and even the sound quality and even the presentation, the really good presentation. Thank you so much, Stephen. So let's invite in right now Rodrigo Cesar Bergini for the next presentation. He will talk about plastic and sustainability in Brazil, market figures and opportunities. Are you there? Hello, Rodrigo. How are you today, man?
Hello, Leandro. How are you?
Great.
How are everyone? Yeah, nice to be here. Thank you very much for the invitation. So let me share my screen with you.
I really appreciate it. So just to talk a little bit about Rodrigo. Rodrigo, he is material engineer, postgraduated in marketing, specialized in thermoplastics, composite material, and elastomer. Rodrigo has 20 years of career experience developing new business for special chemicals and mobility industry. Great, Rodrigo. Right now I can see your screen and you can move forward your presentation. Thank you so much again.
Thank you, Leandro. Thank you for the introduction. So over these 20 years of career, 10 years with composites, 10 years with elastomers, and in composites, both thermoplastics and thermosets. And I am also a voluntary member of ABIPLAST. ABIPLAST is the Brazilian Association of the Plastics Industry in Brazil, and I'm a member of a network for plastic sustainability. So we're going to bring some figures about the market, about challenges ahead, especially in the mobility sector around development of new applications involving plastics, composites, and I will bring also important figures about recycling and sustainability. So the central point is why lightweight materials, thermoplastics, composites will grow in the mobility markets. And we'll discuss about the thermoplastics recycling value chain. We'll discuss about figures and opportunities. So first thing is to understand that we have a perfect storm forming, bringing a lot of pressure on lightweighting in the mobility markets, because we have mega trends involving urbanization, globalization, which brings pressure for lowering emissions. We have changes in the transportation trends, with public transportation growing. We have new business models coming in the transportation markets, shared mobility. We have new autonomous vehicles. We have electrification coming. We have the trends in the automotive industry itself, market concentration. We have 50% of the automotive sales coming from the BRICS. So there is a strong trend in the whole market ecosystem that forms a perfect storm for pressure on lightweighting. On top, we have the growing requirements on CO2 emission reduction in North America, Europe, and Asia. I have to agree with what the guys from About told, that Brazil is a bit shy, still a bit shy in terms of requirements for lowering emissions, but we have a lot of incentives through Route 2030 to support projects that improve fuel efficiency and reduce emissions in vehicles. So it's a global trend and it's no way back. All the OEMs are pushing forward towards improving design and reducing emissions in vehicles. And on that challenge, specifically talking on lightweighting, 64% of the problem doesn't depend on weight. You can change the powertrain system of the vehicle. Here in Brazil, if you bought a car in the 90s, if you had a 2.0 liter car, you would be a fancy guy. It's powerful, but it's polluting a lot. Nowadays, a 1.0 liter turbo engine car has the same power, but much less emissions. So powertrain system is responsible for 64% of this problem. 36% depends on weight. It means that OEMs have to reduce around 300 to 400 kilograms in weight to meet the CO2 gap emissions, especially in Europe, where we have the toughest requirements for CO2 emissions. And then, with the challenge ahead to reduce emissions, we have to choose between materials. You have the mega trends in the steel market, as we saw, high strength steel coming, new materials, new alloys. Aluminum is growing a lot. And we have also composites. I don't know how familiar you are, but composites is when you have a resin, a polymer, usually a polymer matrix, and you have a reinforcement system that could be glass fiber or carbon fiber or aramid fiber or even natural fibers. When you put those materials together, a resin and a fiber, you have a sum of the properties of the materials and you achieve outstanding mechanical performance. So it allows you to replace steel, aluminum in semi-structural and even in structural parts of the vehicle, but it has a lot of challenges, because if you think about the process complexity with steel and aluminum, it's more or less the same manufacturing route technology. If you move to composites, it's going to require to completely change the production mindset. So it's a gap and it requires development. In terms of weight reduction potential, in the other hand, with those materials, you can achieve ultra high mechanical performance. I would say that with, for example, with tapes, you can achieve over 3000 MPa in tensile strength with carbon plus epoxies or carbon plus a thermoplastic matrix. But if you think about how to design properly the structures with this mechanical performance level, it's a must. In terms of cost, composites part to part are more expensive, but to work with composites require you to think about the whole vehicle design. It's not a black metal, like you have the same design of a metallic part and make the transition into a polymeric part, but it's going to require a whole redesign in the system, because there are two benefits that comes when working with polymeric materials. First, the design freedom. You have more design freedom with polymeric materials, and you have functional integration. You can reduce significantly the amount of components in the structure of a vehicle because of the mechanical performance of the material. So in the short term, we see this one-on-one replacement. Aluminum is expected to replace steel in a lot of applications, but in medium to long term, we understand that functional integration, redesign will be a key opportunity for growing the use of polymeric materials in vehicles. If we think about then the choices in terms of manufacturing routes, this is also a big opportunity, because in Brazil, we don't have a highly mature industry for, I would say, for short cycle and structural composite parts. I would say that it's a developmental area in our country. I believe in UK you have a more mature market for performance composite parts. So this is opportunity, especially when we think that when we go to structural performance composites, where you achieve over 800 MPa in strength and over 30 GPa in stiffness, with densities below 1.6 grams per cubic centimeter. This is the main advantage, how much strength and stiffness you deliver with the density of the materials. Then I believe that there is a lot of opportunity to collaborate with European companies to bring technology to Brazil into new manufacturing routes. So we have thermosets, we have thermoplastics, but there is one special reason why thinking carefully about thermoplastics is sustainability. This is on top on the advantage of thermoplastics. It's easier to recycle thermoplastics than thermosets, because you can shred a material, you can bring it back into an extrusion, have it into pellets, and injection mold new parts, or you can form new parts very easily out of residues of end-of-life components in a vehicle or any other application. So just to give you an overview then about technology, to grow polymers, composites into the mobility markets, in the region, we need more understanding around the performance of the materials, different resins, fibers, matrices, and manufacturing routes. This is a development area. Short cycle manufacturing of structural thermoplastic composite parts, especially compression molding with tapes. This is a growing interest, especially in the heavy mobility industry for trucks, for implements. You have this need to reduce weight significantly in structural parts, but you need fast production cycle rates. When I say fast cycle, I say that it's one part every minute or less. Functional integration and design. This is another area of work, because today I would say that OEM concentrates their design capabilities in their headquarters in Europe or North America or Asia. And here the engineering of OEM is more focused on bringing the technology and improving for regional requirements. So there's no much development in terms of introducing a completely new technology in structural parts. So this collaboration with the OEM in their headquarters, in their engineering headquarters, is very important, and approximate the local engineering of the OEMs with their headquarters to understand what's going on is very important. And in terms of hybrid material solutions, I bring here an example of integration of composites with metallic components. And I have to say, on aerospace, we mentioned a little bit about aerospace in the previous presentation. Airbus is using glare. Glare is a structure composed by composite, it's glass fiber, and aluminum. And it's a material that brings laminates of glass fiber, epoxy resin, and aluminum to provide very, very strong impact resistance and fatigue resistance. It's a fantastic material. So by learning on how to integrate wisely the materials, polymers and metals into smart structures, it's going to drive the future of design of vehicles. So jumping now into the plastics and the recycling industry in Brazil, the thermoplastics manufacturing industry, we produce over 7.3 million tons of thermoplastic components or parts or anything that transforms resin into a final product. So this is the number of the industry itself, the conversion industry itself. It's 7.3 million tons. It has grown over 2019, even in a very difficult year for us, considering the pandemics, considering all the scenario. We're producing 7.3 million tons. We have over 300,000 employees in our market. We have more than 11,000 companies. And starting to talk about recycling, if we consider that we generate about 2.6 million tons of post-consumption material, when I talk about, for example, short usage materials, like for example, a plastic knife, for example, or a plastic fork, post-consumption plastics for packaging, for food packaging, for example, that goes to landfill and are recovered for recycling, we generate over 2.6 million tons of material that could be addressable for recycling, of post-consumption plastics for recycling. And our industry has transformed 838,000 tons of post-consumption resins. So it's a quite impressive number, 24% of the addressable market, but there is a lot to grow. There is a lot to grow. So we have space to recycle more. We have an employment of over 10,000 people in our recycling industry. We have over 1,000 companies and an average 10 employees per company. Just to give more highlight on this number here, so I believe I made a small confusion, sorry. We have 3.4 million tons addressable for recycling. We recycle 838,000 tons, and we have 2.6 million as an open space to grow. So it's a big open space to grow in recycling in Brazil. This is what we're trying to show here. And this is a map of the plastics recycling value chain in Brazil. The industry, as I mentioned, it was 7.1, now it's 7.3. We exported 0.3 million tons of plastics, and we have imported 800,000 tons of thermoplastics. So we have this balance of how much we export, how much we import, bringing a total market of 7.1, 7.3 last year. When we say in use, we break down in use and residues, because in use is long-lasting products. For example, the plastic parts are still in the vehicles, are still in durable products, so they are in use. And we generate 3.5 million tons in residues, which are single-use plastics. For example, you have a birthday party in your house, you serve your piece of cake in a plastic plate. This plastic plate you use only once, and then you dispose. So we generate this residue, and it's 3.5 million tons of plastic residues. Of that, our industry converted 838. We had 116,000 tons of losses, and we had 2.7 million tons of material disposed in landfill. So this is a very strong number for us, and we want to grow the use of recycled materials. And of course, our target is to reduce more and more the amount of plastics being disposed. So to incentivize the investment, for example, if we grow 1 percentage point in recycling rate, we create 8,554 direct employments in the 3 phases of the value chain. We are considering cooperatives, we are considering recycling companies and manufacturing industry, and we are reaching D&E social classes, which is very important. And to grow 1 percentage point, we generate 170 million reais in products made out of recycled plastics. Not considering the other benefits related to the manufacturing chain. 75% less energy, less 450 liters of water in production, the greenhouse gas emissions reduction. So it's very important to grow recycling in our market. And what's going on in terms of recycling? You saw a slide about chemical recycling. It's an important point for us. But we are also advancing in mechanical recycling, trying to achieve better quality of the post-consumption material, reducing at most the levels of contamination of the collected material, and developing applications in the mobility industry involves understanding the levels of performance, understanding the right approach in design, how to maximize the competitive advantages with those materials, and designing new business models. Those are important factors to grow the use of recycled materials in the mobility industry. And last, there is also a trend to create value with post-industrial residues, not just the post-consumption materials, but there are a lot of challenges also involving plastics which are processed in the value chain, and you have residues from companies that are difficult to recycle, and you can find very good solutions out of industrial residues as well. So it's a very short overview. This is my contact information, and I'm available for any questions you may have.
Great, Rodrigo. Great. Thank you so much. Thanks so much for a really nice presentation. Right now, I even invite Steven to open your camera, to open your microphone, please, just to start our section of questions and answer. So for the plastic section, we have just two presentations. I really emphasize the audience. If you'd like to make some question, please feel free to put over here on the chat. And right now, I have just a question for Steve, that it was our first one. In your opinion, what is the best ways to connect the companies in UK, or to find a specific company with specific specialized plastics area, for example, Steve? How we can find some contacts in UK, in your opinion?
Sure. Yeah, and I think for anyone from outside, and we have the same problem, it's very difficult. You start with 6,200 companies, and how do you find the one you want? So for our side, I would say three things. Is one, we have that directory, which is 2,800 companies within the industry. So I think that is the vast majority of them. Within there's about 4,000 categories. So you can get very, very, very specific by the kind of companies you're looking for. We also have the document, the members directory that people can flick through. People could email me, shunt@bpf.co.uk. And then the final thing is we have a website called PRAS, P-R-A-S, Plastics Rubber Advisory Service.com, which basically goes to the 30 members of staff at the BPF, and then we find the people for you and connect them, right? So it's kind of quite a bespoke solution.
Great, great. We have a technical questions over here, Rodrigo, from the audience. I think that's really good, according that you have a really good knowledge on the technical area even. Do you see some tendency to substitute, to change the plastics or other material, or opposite continue? What do you think?
Yeah, it's a continuous reflection, as I said, because plastics will not solve all the problems, and metals will not solve all the problems. And this is a continuous discussion, because I believe in the future, the functional integration of different materials will domain. The smart use of materials to reduce the amount of part count, especially when you talk about EVs, electrical vehicles. The design is much simpler. The number of components in the vehicle is so much smaller. So we see that the growing use of composites, of aluminum and high strength steel in this market space, because as you increase the performance of the materials, you can simplify design, you can reduce weight, and you can increase efficiency. So this discussion is going to continue forever. There's space for new technologies. We see graphene, for example, coming as a material that can change the landscape of materials. If you reinforce a resin with graphene, you can achieve electrical conductivity, you can achieve you can increase a lot the modulus of the material. So it's a continuous discussion. We're going to debate that forever.
Yeah, even for composite material. So for composite material, we can see even a really good application on that. And even continue with you, Rodrigo. During your presentation, you mentioned about creation with recycling post-industrial residues. What are the challenges behind using post-industrial reduces in the recycling projects, for example, man?
I would like to give you an example. I work for Vitopel. Vitopel is a producer of flexible films for packaging industry. If you open your chocolate bar today, or if you go to drink a soft drink and look at the bottle, you will see the label. That label is made of this polypropylene film that we make here. And there are a lot of challenges because, for example, when you need the barrier for gas, as the guys from aluminum explained, sometimes you join thermoplastics and aluminum to gain barrier for oxygen or for water vapor to preserve the food. When you add aluminum to plastic, it becomes more difficult to recycle. I have an example here in my table. This is a bobbin of a label. So you see aluminum side and thermoplastic white side. And when I have residues of this material in my production, I can say at Vitopel, we generate over 100 tons of a month of this kind of residue. And we try to recover. We shred the material like that. And then we extrude into pellets suitable for injection molding.
For raw material.
And we can sell to molding industry to make parts for mobility industry, for cars. We produce also components for civil engineering applications. So this kind of demand is interesting. And the opportunity with post-industrial residues is that, first, it had no contact with food. So it's a clean residue. So it's easier to recycle products coming from operations than getting the post-consumption material, washing it, and trying to reuse the material. It's traceable, so it can be used also in more severe parts, more mechanical resistant parts. So this is an advantage of working with post-industrial residues.
Great. I appreciate. And for you, Stephen, on the same line about the tendencies, what do you think about it to substitute plastic in other materials? How you can see that kind of tendency, for example, in your market over there in UK?
Yeah, so I think I think Rodrigo is right that it is a continuous thing, and things will go and change. I think for us there is a lot of debate around products made from multi-material, and the recyclability of that. So we've done a lot of work around eco-design. We felt that was one of the big starting points to do this, and engaging with people across the supply chain to make sure they're making the right decision when using plastics and using it in the right way to make sure that it's economically viable. Very important to reclaim it at the end of its life. And then also in terms of substitution, I think it's undeniable over the last decade that plastics has done quite well in many areas, in terms of being substituted for other materials. Within automotive, unquestionably, because of the drive for lightweighting, plastics has played a big role. I think you're right. Thermoplastic composite, I think, has got a big role to play. I think within the UK, we probably need to get better. People like Jaguar Land Rover talk to us a lot about the need to invest and plastics companies to invest in thermoplastic composites. And we're not there yet, say, compared to Germany or other countries, but we are moving forward in that space, and that will help us take more material. But then the other trend for us is actually, interestingly, especially in packaging and other areas, to significantly reduce the amount of plastic. So it's quite staggering how less plastic we are using in packaging, yet far more items are made of plastic, because we are reducing and lightweighting within there the amount of plastic that goes in products. So it's not just about changing the material, it's also about using less to get more, I think, is an important part of it.
Great, great. And even continue with you, Stephen. What do you think the main focus of plastic firms in the UK at this moment? What they are putting focus right now?
Yeah, I think really largely Blue Planet 2. I don't know whether that was a big thing in Brazil with David Attenborough, but I think that really started a debate around plastic and what its role in the world was around sustainability and circular economy. That really started the consumer then demanding various things, and that then led up the plastic supply chain to mean that we could do things that we couldn't do before. Maybe a product costs more money, but it's ultimately more sustainable. And I think there's a big drive within the industry, really. Sustainability, circular economy, increased recycling. I think we've done a lot in a decade, but I think we need to do a lot more. And I think what is really important, events like this I love, is that the world of plastics people to communicate and exchange ideas, and also talk to other materials as well, to make sure that we're all working together to a similar aim, really, and exchange quite openly in terms of what we're doing. But I would say sustainability, recyclability, circular economy, and after that, actually carbon reduction. That's a big thing in terms of how do we decarbonize our industry? How do we get to net zero in terms of carbon emissions? I think that is going to be a huge debate over the next 30 years.
Super, super. Thank you so much. Rodrigo, we have one technical question over here from the audience. Do you know if you have some international standard to cover the properties polymers with reinforced? It's a good question. It's a really good question.
Wonderful question. I would say that composites, polymers with reinforcements in general, they are not isotropic. The properties can change by the type of reinforcements that you are using, the architecture of the reinforcement that you are using, if it's a fabric, for example, if it's a chopped strand, randomly distributed in a matrix like we have here in this part, for example. It's injection molded with short glass fiber in a compound, so it has 30% glass fiber in it. So it's an isotropic material, but composites with layers, when you have fabrics in it or you have tapes in it, they are orthotropic. So usually there are standards to test the composites, to characterize the composite itself. Then you create a material data card that will help you to design a structure. And there are public material data cards, which are mainly addressed by the aerospace market. If you consider the Wichita University, there is a website called NCAMP. I will type here in the chat.
Yes, in the chat. You can include over here in the chat.
NCAMP. So it's the National Center for Aerospace Materials, and they have open database of many different composite examples, and those materials, they are certified for use in aerospace structures. You can access this database of properties and use in your design. We don't have such a solution, for example, in the automotive sector for high-end composite materials. You have to create this database based on the architecture of the material that you are designing. This is a problem, and this is an advantage. The beauty of composites is that you have this flexibility to deal with the amount of polymer, amount of reinforcement, change the architecture of the reinforcement to achieve the performance that you need. But in the other hand, in terms of standardization, you have to specify, once you create this build of material, once you specify the architecture of your composite, you have to create a material data card for that composite. And then there are several standards for testing composites to support this data card creation. And if you share your contact information, I can share some standards for testing composites with you. Great.
Would you like to add something over here, Stephen?
No, I think that was a very good answer by Rodrigo.
Very well explained by Rodrigo. Great, great. So, gentlemen, again, thank you so much for a really nice presentation. It was a pleasure to see you again, Rodrigo, so we know each other, and to see you over here, Stephen. Thank you so much for the presentation. So right now we are going to our final remarks. If you would like, please just to turn off your camera. Thais, if you'd like, please just to share the screen about the event chart, just to include it over here that people knows about that we did. In fact, it was a really great seminar. I really appreciate again to the all audience about the questions, about to special thanks, of course, to the speakers to share your knowledge between us. It was a really great seminar because we spoke about aluminum, we spoke about steel, we spoke about plastics material. So in fact, it's a multi-mix materials, of course, to offer to the automotive market. Once more, I really would like to thank to the sponsor, British Government in Brazil and the UK Department for International Trade, DIT, in name over here of Mr. Douglas Barners. Thank you so much to attend that seminar. So just to remind you, next March 25, we will have a second SAE Smart Track in UK, okay, on 25. There will be a second one that will focus on batteries. I really incentive you everyone to enter at the SAE website, just to double check the agenda over there, and of course make your description. Follow the SAE in the social media and access saebrazil.org.br for more informations. Ladies and gentlemen, thank you one more time. We are totally available over here at SAE Brazil. Have a great day, everyone. Thank you. Bye now.
Bye-bye. Thank you.
Bye now.